Imagine changing a database configuration and accidentally breaking your password reset emails. It sounds unrelated, but in many code bases, these two things are dangerously coupled. Today, we're going to fix that using the single responsibility principle. Welcome. We are looking at the single responsibility principle, or SRP. It is the first of the solid design principles. The textbook definition states that a class should have one and only one reason to change. But for many developers, that definition is a bit abstract. So let's look at it through a practical lens. A class should answer to only one actor or stakeholder. Let's look at a typical user class written by a junior developer. It looks logical at first glance. We have a user class that holds data like the username and password, but look closer. It also has a method to save to database and a method to send welcome email. This class is now responsible for three things: business logic, data persistence, and notification services. We call this a God object or a violation of SRP. If the database administrator changes the schema, this class must change. If the marketing team wants to change the email subject line, this class must change. Why is this a problem? It creates coupling. If you modify the save to database method and introduce a bug, you might prevent the user from sending emails even though the email logic was untouched. Furthermore, testing this is a nightmare. To unit test a simple username validation, you would have to mock the entire database connection and the email service. That is too much friction. Let's refactor this using SRP. First, we strip the user class down to its core responsibility, holding the state of a user. It should be a plain object containing only properties like ID, username, and email. It does not know how to save itself, and it certainly doesn't know how to send emails. It is just data. Next, we delegate the persistence logic to a dedicated class, often called a repository. Here we create a user repository. Its only job, its only reason to change, is if our database technology or schema changes. It takes a user object and handles the SQL or ORM instructions. The user doesn't care if it's being saved to MySQL, MongoDB, or a text file. Finally, we extract the notification logic. We create an email service. This class encapsulates everything related to SMTP servers, API keys, or HTML templates. If the marketing team wants to change the email wording, you edit this file and this file only. The user class and the user repository are completely safe from these changes. So, how do we use them? We use a controller, or a use case handler, to orchestrate the process. The controller creates the user object, passes it to the user repository to save, and then calls the email service to send the notification. Each component does exactly one thing. This makes your code modular, readable, and most importantly, easy to test. By applying the single responsibility principle, we've turned a fragile God object into a robust, flexible system. If you found this breakdown helpful, please comment below. And don't forget to subscribe for more architecture tips. Happy coding.